Hi students, as a part of the polymeric unit or polymers unit, today I am going to discuss about the natural rubber and its vulcanization. So before going to discuss about the vulcanization, first of all we have to discuss some basics related to the natural rubber. Some basics related to the natural rubber. So those basics are, what is the natural rubber and how the natural rubber is being prepared. So first and foremost we have to discuss about what is the natural rubber. So natural rubber is the polymer of isoprene. Now since the natural rubber is the polymer of isoprene, we can say that the monomeric unit by which the natural rubber can be prepared is isoprene. As it is the polymer of isoprene, we can say that the monomeric unit required for the preparation of the natural rubber is isoprene. And do remember that the natural rubber is also called as polyisoprene. It is also called as polyisoprene. Now, we are going to discuss about how this natural rubber is being prepared naturally. Now, what is the monomeric unit for the preparation of the natural rubber, students? The monomeric unit is isoprene. Now, what do you mean by isoprene? Isoprene is 2-methyl-1,3-butadiene. 2-methyl-1,3-butadiene. First and foremost, let us see the structure of 2-methyl-1,3-butadiene or isoprene. Now, first and foremost, while writing the structure of any of the organic molecule, we have to know how many carbon should be a part of it. Now, as it is 2-methyl-1,3-butadiene, which stands for 4 carbons. Which stands for 4 carbons. Now, arrange the 4 carbons. Arrange the 4 carbons. 1, 2, 3, 4. Arrange the 4 carbons. Now, after arranging the 4 carbons, now label the 4 carbons. 1, 2, 3, 4. Now, as it is 2-methyl-1,3-butadiene, at second position we have to place methyl group. At second position we have to place methyl group. And as it is the butadiene, it stands for the double bond. Diene stands for 2 double bonds, right? Now, the position of one double bond is first position and the position of the second double bond is third position because it is 1,3-butadiene. 1,3-butadiene. Now I'm writing the double bond. I'm labeling, I'm representing the double bond with the blue color. So 1, 3 of the. Now, it is the basic skeleton, students. So, once the basic skeleton of the organic molecule is formed, now we have to ensure the valency of the carbon. As the valency of the carbon atom is 4, we have to ensure 4 bonds around each and every carbon atom in a organic molecule. If it is lacking the bonds, then we have to place the hydrogens. So accordingly, around the first carbon, students, how many bonds are there? 1, 2. So it is lacking the 2 bonds in order to satisfy its valency. So we have to place the 2 hydrogens over here. Now, coming to the second carbon, around second carbon, 1, 2, 3, 4. So the carbon valency has been satisfied, so there won't be any hydrogen at the second carbon. Now at the third carbon, 1, 2, 3. So 3 are there, it is lacking 1 bond. Since it is lacking 1 bond, we have to place 1 hydrogen over there. Now around the fourth carbon, 1, 2. 2 bonds are there, so it is lacking 2 more bonds in order to satisfy the valency of the carbon, which is 4. So what we need to do, students, we have to place the 2 hydrogens. So this is the structure of isoprene. This is the structure of isoprene. Isoprene. It is also called as 2-methyl 1,3-butadiene. 2-methyl-1,3-butadiene. 2-methyl-1,3-butadiene. Now this is the isoprene, which is the monomeric unit which undergo polymerization, resulting in the formation of polyisoprene, and the polyisoprene is the natural rubber. Now students, we have two categories of polymerization. In fact, three categories. The one is addition or chain growth polymerization. Second one is condensation or step growth polymerization. And third one is copolymerization. Now among these three polymerization, since it is the single unsaturated monomeric unit, it will undergo addition or chain growth polymerization. If two different unsaturated monomeric units are present, then they will undergo copolymerization. If the monomeric units contains the functional groups, then they undergo condensation or step growth polymerization. Now, this particular isoprene is single unsaturated monomeric unit. Since it is single unsaturated monomeric unit, it will undergo addition or chain growth polymerization. Addition or chain growth polymerization. So, addition or chain growth polymerization. Now, already I have explained in the previous classes that during the polymerization, whatever the double and single bonds which are there in the plane, will convert to single and double bond respectively during the polymerization. So n number of molecules of this. Now, CH2 strengths, CH2, right? CH2. Now, this double bond will convert to single bond strengths. Now, this double bond is converted to single bond, and these are the bonds which are there in the plane. And the double bond converts to single bond, and single bond converts to double bond during the polymerization. Only those double and single bonds are being converted which are in the same plane. Now CH2 is there, students. Now the double bond will convert to single bond. Now C. Now here the single bond is there, but it is not there in the plane. Since it is not there in the plane, so the single bond won't be converted into the double bond. So CH3, and this is the single bond which is there in the plane. So since it is there in the plane, it converts to double bond. Next, CH. Next, double bond converts to single bond, followed by CH2. Now, during the polymerization, whatever the alphabet which is there before the unsaturated monomeric unit becomes subscript for this. Now, this is our polyisoprene, or it is also called as natural rubber. So this is how the natural rubber is being prepared naturally by the addition or chain growth polymerization of isoprene or 2-methyl-1,3-butadiene. Now do remember this, that the natural rubber which is so obtained by the addition or chain growth polymerization of the isoprene or 2-methyl-1,3-butadiene is linear polymer. It is linear polymer. And already I have discussed in n number of videos that among the linear, branched and cross-linked polymers are strong, stiff and rigid in nature. Now it is a linear polymer. Now since it is a linear polymer, definitely its stiffness, strength and rigidity is very less. Very less. Now we have to discuss the properties or characteristics or disadvantages associated with this natural rubber, which is a linear polymer. So before that, students, in which industry the rubber is extensively used? The rubber is extensively used in automobile industry for manufacturing the tire and tube of an automobile. Now, whatever the rubber by which the tube and the tire is made up of, should withstand to cold conditions and it should withstand to hot conditions, because automobile is the one which will not be stagnant at one particular place. The automobile, the name itself implies that it will move here and there. For example, car, tires and tubes of the car, right? Now this is the one which moves across the world or across any area, right? Now across any area, so definitely it will be influenced by the cold conditions, it will be influenced by hot conditions. Now whatever the conditions are, it should be compatible, it should be unaffected by those conditions. But this property is missing in the case of natural rubber, students. Natural rubber. Because the natural rubber is not heat resistance, but the rubber by which the tube and tire of an automobile is made up of should withstand to cold and heat, because the automobile is the one which will move here and there. So definitely it will be under the influence of heat as well as cold. So definitely the tire and tube of the automobile must be resistant to the cold and hot conditions. This property is missing. And the second thing, the rubber by which the tube and the tire is made up of should not absorb maximum amount of moisture, should not allow maximum amount of water. Because whenever the water is penetrating inside the tire and tube, which is made up of the rubber, then during the penetration of the moisture or the water molecules, these water molecules will break the bonds which are there between the adjacent atoms in the tire or tube atoms. So by which the wearing and tearing of the tire and tube takes place. Wearing and tearing of the tire, that is, the damage of the tire and tube takes place. Damage takes place. Right. So this is the second disadvantage. It absorbs more amount of moisture. But whatever the rubber by which the tire and tube is made up of should not absorb more amount of moisture, because whenever the water molecules are penetrating, what is happening, students? So definitely during their penetration, they will break the bonds which are there between the adjacent atoms of the tire and tube molecule, thereby wearing or tearing, that is damage of the tire and tube takes place. That is, whatever the rubber by which the tire and tube is made up of should not absorb much amount of moisture, should not absorb much amount of water. This property is lacking, students. This property is lacking. Now coming to the third point. So whatever the rubber by which the tire and tube of an automobile is made up of should be moderately elastic. If it is more elastic, then just imagine yourself in the car. If it is more elastic, if the rubber which is more elastic is used for manufacturing of the tube and the tire, then what happens, students? Jumping of the car takes place because it is more elastic in nature. On the other hand, it should not be least elastic. It should not be rigid in nature. If it is rigid in nature, then the wheel of the automobile just behaves like the road roller because it is very rigid. So if it is very rigid, the pickup is very, very less. Just imagine your journey on the road roller. You cannot imagine your journey on the road roller because there won't be any pickup, because the wheels are made up of the metal. Now, if there is no elastic nature associated with the rubber, then it will not fit for the manufacturing of the tire and tube. So definitely, whatever the rubber which is being used for the manufacturing of the tire and tube should be moderately flexible, students. But this property is also missing in the case of natural rubber. It is more elastic in nature. This is another poor quality associated with the natural. But the last but not the least, it is not abrasion resistance. And automobile is the one which is moving here and there. And whenever it is moving here and there, so definitely on the road, there will be so many substances like the sand, stones, nails will be there. So, if it is not, the tire and tube is not resistant to these nails, stones, sand particles, then the friction takes place. Whenever the friction takes place, the tire and tube will wear and tear. Wear and tear of the tire and tube is nothing but the damage of the tire and tube. Abrasion resistance means it should be resistant to the friction. But our natural rubber is not associated with this quality. It is not resistant to abrasion. So these are the 4 properties or characteristics or disadvantages or poor mechanical properties associated with the natural rubber, which will make the natural rubber unfit for the manufacturing of the tire and tube of an automobile. The first one is, it is not resistant to heat. It will absorb more moisture. Third one is, it is more elastic in nature and it is not abrasion resistance. So these are the 4 poor mechanical properties associated with the natural rubber, which makes the natural rubber unfit for the manufacturing of the tube and tire of an automobile. So there is a need to improve. The poor mechanical properties associated with the natural rubber, by which we can make the natural rubber fit for manufacturing the tire and tube of an automobile. Right. So in order to make the natural rubber fit for the manufacturing of the tire and tube of an automobile, the scientist named as Charles Good. In the year 1839 added the sulfur powder. So whenever the sulfur powder was added, then he noticed that the mechanical properties, the poor mechanical properties associated with the natural rubber have been enhanced. That is, the mechanical properties associated with the natural rubber was improved. Right. Charles Good in 1839. What is done, students? He has added the sulfur powder in order to improve the mechanical properties, poor mechanical properties associated with the natural rubber. This process of addition of the sulfur powder to the natural rubber, in order to improve the poor mechanical properties associated with the natural rubber is called as vulcanization. Is called as vulcanization. Is called as vulcanization. Vulcanization. Is called as vulcanization. Now let us see. So this is the reason, students. So what you literally do is, you will not understand anything about the vulcanization. What you will do? Just you will mug up or memorize what is the vulcanization, and for the definition you will get 2 or 3 marks. But what for the vulcanization is being done? You have to study in the conceptual manner, not memorizing the things. But what you are doing, you are memorizing each and everything. That is what happening with you students. What for the vulcanization is being done? I have explained each and everything behind the vulcanization process, the history behind the vulcanization. That is the reason. In order to improve the poor mechanical properties associated with the natural rubber, vulcanization is done, students. But don't mug up or memorize what is the definition of the vulcanization. It won't give the knowledge for you. It might give the marks for you, but it won't give the knowledge at all. So, during the vulcanization process, what we need to do is we have to take a chamber, and in the chamber we have to pour the natural rubber, and we have to pass either the steam or hot air into the chamber in which natural rubber is present. Now, under the influence of the steam or the hot air, around 120 to 140 degrees centigrade of temperature is being maintained in the chamber which comprised of the natural rubber. Under the influence of this temperature, which is ranging between 120 to 140 degrees centigrade, the natural rubber becomes soft. Once it becomes soft, then we need to add the sulfur powder to it. Along with the sulfur powder, we need to add some catalyst. Catalysts like zinc salts are being added as the catalyst or accelerators. Now, whenever the sulfur powder is added to the softened natural rubber, then what happens? What happens is the cross linkages are developed in between the adjacent monomeric chains of the linear natural rubber, by which the linear natural rubber will be converted into the cross-linked natural rubber, which is the vulcanized natural rubber. It is very easy to remember the structure of the vulcanized rubber. No need to memorize the structure of vulcanized rubber, students. Just I am writing that. Polyisoprene or natural rubber, CH2, single bond, C, CH3, double bond, CH, next single bond, next CH2. Now write down the same moiety, students. There is no need to memorize. Again, CH2, next single bond, next C, next CH3, next double bond, next CH, next CH2, so on. So we can combine another moiety, that is CH2, CH3, double bond, CH, CH2 we can combine. Now, what is this, students? This is the polyisoprene or the natural rubber, which is the linear polymer. Now, whenever sulfur powder is added and certain amount of temperature is being maintained, which will range between 120 to 140 degrees centigrade. Now, what happens is, so write down the vulcanized structure in this fashion only, students. In this fashion only, how I'm going to write on the board. So write down the same thing here. CH2, no change. Next, CH3, because it is a polymer, right? So CH3. Next, double bond as it is, CH as it is, CH2. Next, single bond, CH2. Next, a single bond, CH3, double bond, CH. Next, single bond, CH2. So whenever the sulfur powder is added, now what happens? Just what you need to do is, in order to write the structure of the vulcanized rubber, which is the cross-linked rubber, just place the mirror over here. If you place the mirror over here, what happens, students? Whatever the atom, whatever the group which is oriented at the top, now it will orient at the bottom. Whatever the group, that is here it is methyl group which is oriented at the top, now it looks bottom. It orients at the bottom. Now write down the same thing, students. CH2, no change. Next, CH3, double bond, no change. Just CH3 was at the top, that is top in the sense it is at the top, and it is at the bottom, that is above and below. CH. Next, CH2, no change, students, no change. Don't become panic by seeing the structure, it is very simple. CH2. Next, single bond, C. Now it is above, it will below because it is a mirror image. Double bond, CH, CH2. Now, during the vulcanization, what happens is, whenever the sulfur powder is added to the natural rubber, the sulfur atoms adds across the double bond, students. Adds across the double bonds. Now there will be the change only at the double bond because the sulfur atoms of the sulfur powder are adding only across the double bond. Now in order to get the structure of vulcanized rubber from this basic moiety, what you need to do is, with respect to the double bond, on left side write down the sulfur, and right side write down the sulfur, and convert the double bond to single bond, because the sulfur atoms of the sulfur powder are adding across the double bond. Now the change occurs only at the double bond, only at the double bond. Now where is the double bond, student? Here. So with respect to the double bond, we have to place the sulfur, students. And with respect to the double bond, because the addition is only taking place across the double bond, the change only occurs at the double bond, the remaining moiety is intact like that only, it will not change at all. Next, double bond. So with respect to the double bond, on right side, sulfur. Now the remaining moiety is one and same. Now what we need to do? The double bond should be converted to single bond. That's it. Now, next, across the double bond is there. Left side, with respect to the double bond, we need to add the sulfur. With respect to the double bond, on right side, we need to add the sulfur. Right. Now what we need to do, students? The double bond should be converted to single bond. The same thing here also. With respect to the double bond, on left side, sulfur. With respect to the double bond, on right side, sulfur. And the double bond should be converted to single bond. So there is no change in the remaining moiety because the sulfur atoms are forming the cross linkages only across the double bond. Now the double bond, With respect to double bond, on left side, sulfur, on right side, sulfur. Now the double bond should be converted to single bond. So this is your structure of vulcanized rubber, students. This is vulcanized rubber. This is vulcanized rubber. Vulcanized rubber. Vulcanized. Right. Now this vulcanized rubber is a cross-linked rubber, and as we know that the cross-linked polymer is stiff, strong and rigid in nature. Now this vulcanized rubber is strong, stiff and rigid in nature. Now what we have done with the help of vulcanization, with the help of the addition of the sulfur powder, we have converted the linear natural rubber into cross-linked natural rubber, which is the vulcanized rubber. We have converted the linear natural rubber into cross-linked natural rubber, which is the vulcanized rubber. So by which whatever the poor mechanical properties was associated with the linear natural rubber now convert into the good mechanical properties, because the linear natural rubber has been converted into vulcanized natural rubber, and this vulcanized natural rubber is associated with all the good mechanical properties because it is the cross-linked polymer. That is, now it is resistant to heat. It will not absorb a maximum amount of moisture. Next, it is moderately flexible, students, and it is abrasion resistant. So these were the poor mechanical properties which were associated with the natural linear polymer. But whenever it has been converted into the cross-linked natural polymer, then the poor mechanical properties which were associated earlier with the linear natural rubber have been improved when it has been converted into the vulcanized rubber with the addition of the sulfur due to the development of the cross linkages across the double bonds present in the linear natural rubber. Now lastly, we have to discuss to how much extent we can add the sulfur powder. We can add the sulfur powder to an extent of 32%, students. 32%. We have to add the sulfur powder to an extent of 32% only, not more than that. Can you tell me what could be the reason? Just guess the reason. Guess the reason. Because if we add the more amount of the sulfur powder, more number of cross linkages are being developed. When the more number of cross linkages are being developed, then it loses its flexibility, it loses its elasticity, and it becomes rigid in nature. It becomes rigid in nature. Absolutely rigid in nature. Whenever it becomes absolutely rigid in nature, now making use of this vulcanized rubber comprised of greater than 32%, if we manufacture the tire and tube, it will just behave like a road roller. That is, there won't be any hiccups. So that is the reason we have to add only 32% of the sulfur during the vulcanization, not more than that. I hope you understood this natural rubber and its vulcanization, students. So this is very important question from the examination point of view. So thanks for watching.